Alright, here's our third and final example from our solving systems of equations with substitution. So we've got another linear system in front of us. The second equation looks like it sets up nicely. Let's isolate the x. So if I subtract my 2y over, we'll get x equals negative 2y minus 2. Not too bad. And now, like we've done previously, let's substitute that in. We're going to replace the x in that first equation. So I'd have 3 times negative 2y minus 2. Again, this just replace the x there. Plus 6y equals negative 6. We've effectively eliminated our x from that equation. Let's combine like terms and clean this equation up. So let's distribute that 3. Negative 6y minus 6 plus 6y equals negative 6. You can maybe see something interesting is going to happen here. So if I combine like terms, negative 6y plus 6y is 0. And let's add that 6 to the other side. So negative 6 plus 6, well, that's going to be 0 as well. So 0 equals 0. Well, the previous example we saw something like 0 equals negative 5, I think. Well, that was not true. That told us no solution. Well, 0 equals 0 is true. So when we run into something like that, that tells us that there's actually an infinite number of solutions, or this is a dependent system. So we're still not done. We are going to write an answer. The way we want to write that, though, is in terms of x. So in terms of x. So let's go back to one of these equations, and we want to solve and get the y by itself, basically. So it's written in terms of x. And so it doesn't matter which one we go to. Let's just go to this equation here. So x plus 2y equals negative 2. I want to solve that for y. You may be saying, why is he solving that for y? I'll show you. So let's get y by itself here. So 2y equals negative x minus 2. Now let's divide that 2 over. So y equals negative 1/2 x minus 1. Or we could just write negative x over 2, however we want to do that. Now here's why we did that. Because this is a dependent system, x could be anything basically. So we're going to say, well, x could be x. Basically, you could plug anything you want for that. What would that make y? Well, that would make y negative 1/2 x minus 1. Or again, I could write negative x over 2. Either way I want to write that. So this solution looks a little bit different, but this is the way we're going to write our answer. So x and then the y equivalent of x, but then we only have one variable instead of just saying, oh, it's x and y. Well, it could be anything. This y value still depends on what you plug in specifically for x. So that's an example of a dependent system.